Alright, here's a problem like number 5 that will work out. So here's my picture, and what we have is a box, and we're going to fold it so the dotted line is going to be the bottom of our box. So when we fold it up, we're going to have a box like this, and it's going to go up like that so we can fill it up with stuff. And our height will be x. Alright, we're going to cut these pieces out and get rid of those. So what we're going to do is take our box here, and we want to make the biggest, or the box that will hold the most volume. So each side, we're going to figure out the length of each side. So our first side is this side, 20. Now 20 is the whole width, but we're going to cut this piece out. So we're going to cut out x on either side. So it's 20 minus 2x. Alright, that's going to match up with this side right here. That's 20 minus 2x. When we figure out this side, we're going to do the same thing. We're going to start with 6, but we're going to cut out this piece and this piece. So we're going to do 6 minus 2x. Alright, and we're going to do our height, which we already know is x. So that's the 3 dimensions of our box. Now to get the volume of these, we would multiply them together, but we don't want to do that yet because we want to figure out what x is. What's x going to give our maximum? So I told you before that when you fold the box, you want to fold it into a cube, but you can't do that because all the sides of this box aren't equal. So we want to make as close to a cube as possible, which basically means we're going to make this side right here and x as close as possible. And then we'll just plug 20 in. So we'll plug that value into the third side here, and that will give us the third dimension. So we're basically going to take this side and make them as equal as possible. And we already said that this side is equal to 6 minus 2x, and this side is equal to x. So let's set those two together and solve it. Now the reason, again, why we're setting these two equal is because we want to make them as equal as possible. If we set this x equal to this side, we're going to get a number that's actually bigger than 6. It would be impossible to fold that box. So always set x equal to the smallest side, which is going to be 6 minus 2x, this side and this side. So that's why we're setting those two equal. Always leave the biggest side off to the side. Don't bother with that to start. So when you solve it, you get 6 equals, I'm going to add 2x to both sides, so you get 3x. So x equals 2. So I know if I make x2, that's going to give me the biggest box possible. Now, how do I find the volume of that box? There's a couple different ways you could do that. What I would do is just plug 2 into every different one of my values here. So let's plug 20 into this equation right here. So I'm going to plug 20 into that. So 20 minus 2 times 2 is 4. So 20 minus 4 is 16. So the length of my box is going to be 16. Alright, so one side is going to be 16. The other side I'll get by plugging 2 into here. And these should be equal, so 6 minus, sorry, that's not a minus sign. 6 minus 2 times 2 is 6 minus 4, which is 2. So my second side will be 2, and my third side, we already know x equals 2. So, how do we find the volume? We do length times width times height, which is 2 times 2 times 16, which gives me 64 centimeters cubed. So that's the maximum volume I can get out of that box. Now let's go back to the start again, real fast, because I know some of you might be a little confused by this problem. It's not that hard. Just think it through. We're given this piece of cardboard right here. And if you already understand this, you can turn it off. But if you can understand this piece of cardboard right here, that's 6 by 20 to start off. We're going to cut out corners to make the biggest box we possibly can. So we're going to cut off a length we don't know yet, so we're calling it X onto each corner. And we're going to fold it up and make a box. Alright? Now, when we fold it up, we're going to be cutting off X, so that's where the 20 minus 2X comes from, because we're going to cut off 2X, or sorry, 1 off X off of each side, so that's going to give us 20 minus 2X. We're going to cut an X here and X here, so that's where we get the 6 minus 2X. And the other side was just X. Now, we would want a cube if we could fold it into a cube, but we can't because we have a rectangular piece of cardboard. So what we want to do is make X in this side equal. Alright, so we're going to make these two sides equal, and that will give us the biggest volume possible. How do I know that? It's just a fact I know about folding up boxes. That's not something they give you. So you basically take the smallest side, which is going to be this side, and set it equal to X, which is that side. I'm not using this side because that's my bigger side. And we can't use that because if we do that, that would run out of room on this side. It would be impossible to fold the box. So just ignore the larger side to start with. So we set 6x minus 2 equal to x, and we solve it. We figure out x is 2. That's going to give us our biggest possible volume. So I just plug 2 back into all of my equations. Alright, and we figured out this side would be 16, the other two sides would be 2. So you do length times width times height, and that gives you 64 centimeters squared. Now, on a multiple choice test, they're going to have to give you the x's here. Which x would give you the largest volume? So on a multiple choice test, you could just plug them in and figure out which one gives you the largest volume. You wouldn't have to even do all this work. But that's where it comes from.